All right, hello, welcome back for more biotechnology. So today we are going to start talking about the main theme of this chapter, which is working with solutions. So let's learn a little bit about what a solution is. So a solution is basically just a mixture of at least two different substances. One is going to be the solvent, and then you may have one or more different solutes. The solvent is going to be the liquid and probably majority component of your solution, and your solutes are usually going to be solids that will be dissolved in the liquid solvent. So in biology, and for most of our purposes in biotechnology, that solvent is almost always going to be pure water, pure distilled deionized water. But if you're dealing with nonpolar solutes that can't dissolve in water, then sometimes you might choose to use a nonpolar organic solvent, something like DMSO, dimethyl sulfoxide. So in this picture that you're looking at here, you're seeing a very basic representation of how a solution might be made. So you have a solid solute, this blue crystalline substance here, doesn't really matter what it is for now, and it is going to be added to and mixed with your solvent. In this case, you've got a certain volume of water. So you mix them together, this solute will dissolve in the water, and then the homogeneous solution that you end up with will be the solution. And solutions like this tend to be clear, indicating that the solute has completely dissolved and mixed into the solvent. So a solution may and often will contain more than one individual solute. A solution can contain many, many solutes. Each solute is going to have its own individual concentration. Concentration referring to the amount of that solute per volume of solution or solvent. So it gives you really an idea of how much of that solute is actually in the solution, adjusted for the volume of that solution. So, like we said, most of the solutes that you're going to be working with are going to be solids that are going to be stored usually at room temperature. So you can see in this picture here, you've got a chemical stock area with many different clear or sometimes brown bottles that store up different types of solutes that you can choose from. So when you're making a solution, you're going to want to make sure that you pick the bottle that has the appropriate solute, and then you want to make sure that you add it to the appropriate solvent, appropriate for whatever solution that you're going to be making. Usually, like we said, that is going to be water. So solutes like this will have to be chosen, and then you're going to find later on in the chapter that you will need to weigh out a certain mass of that particular solute. You don't want to add too much, don't want to add too little. If you do not choose or weigh out the appropriate mass of your solute, the concentration of that solute is not going to be what it's supposed to be. So when you are measuring mass, you'll either be using a tabletop digital scale like what you see here, or in more extreme cases, when you're working with smaller masses, you will use an analytical balance, which are very accurate and very good at weighing out very small and sensitive masses of a particular solute. And as we said, this is all for the sake of making sure that when you make a solution, the concentration of those particular solutes is what they're supposed to be. If you do not mass things out in an accurate or good way, you are not going to end up with the solution made the correct way. So what about choosing a solvent? So we said that usually your solvent is going to be water. So the first thing for us to kind of get out of the way, and I am betting your instincts as a burgeoning scientist probably tell you that you shouldn't be using tap water, and that is for good reason. So tap water contains many undesirable impurities. It contains all types of solutes, salts, some heavy metals. So things that we don't want to actually be a part of the solution. So if you're making a solution and you use tap water, not only is your solution going to contain the solute that you mean to be there, it's going to contain some solutes that you do not mean to be there. So tap water is not something that we are going to use when we are making solutions. Rather, we are going to use distilled and deionized water, which is water that has been greatly purified so that we can be reasonably certain that it is basically pure water with an absolute bare minimum of added solutes. So that will be our source of pure water that we will use in the solution preparation moving forward. So tap water is not totally useless, though. So tap water can be used if you're doing kind of menial things like cleaning glassware, removing soap scum, and things of that nature, but it will never be the final step. After you've used tap water to clean your glassware, you want to make sure that you do your final rinse with distilled and deionized water. That way you can remove any of those impurities from the tap water and make sure that they don't stick to the glassware. So water, as it has it, is a polar solvent. So it is only going to be used to dissolve other polar solutes, so salts and carbohydrates and proteins and things of that nature. So that will encompass most of what you'll be working with in your biotechnology career, but there will be times when you're working with nonpolar solutes, so things like fats and steroids and other sorts of organic molecules that for whatever reason, are nonpolar and do not dissolve well in water. So in those cases, you may want to use an organic solvent, something common like dimethyl sulfoxide, a very commonly used organic solvent, useful in cases in which water is not a good solvent for a particular solute. Okay, and then to wrap up this video, a little discussion on concentration. So all we really said about concentration before is that for a particular solute, it's a measure of how much of that solute is in a particular solution adjusted for the total volume. Well, what you're going to find here is that concentration can actually be depicted in a number of different ways, and they are all fairly common and fairly widespread in their usage in laboratory settings, so I would definitely recommend that you be familiar with all of them. So if we look through here, if we start at the bottom of this table, one of the most common that you're going to find is a concentration metric called molarity. So molarity refers to the number of moles of a particular solute per liter of solution. Okay, well, what the heck is a mole? Well, a later video in this chapter will discuss the concept of molarity and moles, so you need not worry too much about it for the time being, but basically a mole is just kind of a unit of measure for amount of a substance, kind of the same way a dozen tells you how many of something you have. So if you've got a dozen eggs, you've got 12 eggs. If you've got a mole of a particular solute, you've got a certain number of particles of that particular solute. So we will definitely clarify what moles are a little bit later. Another very common one is mass to volume. So this type of concentration metric tells you the mass of that solute contained in a unit volume of solution. So some common units of measurements you might find are grams of solute per liter of solution, milligrams of solute per milliliter of solution, micrograms per milliliter, micrograms per microliter. So you can see the basic ideas there is that you're dividing mass by volume. So the numerator and denominator units may be a little bit different. So either you're using just the standard grams per liter with no SI prefixes, or milligrams to milliliters, micrograms to microliters. So there's a number of different ways that can work, and as we saw in a previous video, you can convert back and forth as long as you do your dimensional analysis, as long as you know things like how many micrograms are in a milliliter, how many milliliters are in a liter, and things of that nature. So the conversions there should not be too terrible, provided that you've gotten yourself some decent practice there. There is another one that deals in percentages. So you might see you've got a 10% BSA solution or a 20% sodium chloride solution. So what does that mean? So percent solutions usually are going to refer to the number of grams of solute per 100 milliliters of solution. So like any metric that deals in percentages, it's going to be a fraction out of 100. So usually if you're doing weight per volume, a percentage will be number of grams per 100 milliliters of solution. So for example, a 10% salt solution would have 10 grams of salt in 100 milliliters of solution, so that 10% of the total volume of that solution, or 10% of the content of that solution, is made up of that particular solute. Yeah, so the example we can look at here, another example, a 1% solution of BSA, that's bovine serum albumin, will contain 1 gram of BSA in 100 milliliters of solvent, or 100 milliliters of solution. That way we know that 1% of the whole solution is the solute. And then finally, one that you're not seeing here, sometimes stock solutions will be especially concentrated, and we'll see some of this a little bit later on in the chapter. So they don't exactly tell you how much of the solute is there, but they give you an idea of what your working concentration should be. So if you are dealing with a 10x concentrated solution, that indicates it is 10 times more concentrated than what you really need it to be. So in order to get your 1x concentration, you would need to do a 10-fold dilution. So sometimes concentration will be depicted in a way like that. And then it's not super duper important, but later on when we talk about molarity, we will see terms like normality and formality. And we will talk about those later, but the basic idea is that normality is a metric that is like molarity, except it tends to be used for strong acids like hydrochloric acid, sulfuric acid, and the like. And formality is going to be used for things like salts. Well, I say that, but usually molarity is what we tend to stick with. So usually you're not going to have to worry about things like normality and formality, but they're at least good to be aware of. All right, so we are going to go ahead and wrap up this video here. I thank you for your attention, and I hope you'll join me next time, and we will start talking about all the ways that we can make new solutions from scratch, and we are going to get some practice dealing with those different measures of concentration that we just talked about. So I will see you next time. Bye-bye.